Hi students, this is T. Balakrishna, chemistry lecturer, GPT Kothagudem. In our last previous part, we learned the definition of acid according to the Bronsted theory of acids and bases, uh, and definition of base according to the Arrhenius theory, Bronsted theory of acids and bases. What is the definition of acid according to the Bronsted theory of acids and bases? The chemical substance which can donate a proton to another substance is called acid. The definition of the base is according to the Bronsted theory is a chemical substance which can accept a proton from another substance is called Bronsted theory of a base. Okay, and previous part we learned a simple example. HCl react with H2O, it is equilibrium with Cl minus plus H3O plus. So in this reaction, HCl is converted to Cl minus by losing of proton. So it is called as an acid. Okay, here H2O is gain the proton from HCl. Here H2O is gain the proton from HCl. It is converted into H3O plus. So that is called base. According to the Bronsted theory of acid and bases. Here acid is HCl is donate a proton to H2O. So that is an acid. Here H2O is accept the proton from HCl. So it is accept the proton. Which substance is accept the proton? That is called base. So HCl is an acid, H2O is a base. So it is a chemical reaction. It has forward reaction, backward reaction. Here we consider the only forward reaction. When you are consider the backward reaction, when you are observe this equation, here Cl minus is converted to HCl. ఇక్కడ Cl minus HCl గా కన్వర్ట్ అయింది. Cl minus HCl గా కన్వర్ట్ అయిందంటే Cl minus is converted into HCl. That means the Cl minus is gain the H plus ion. Both are combined to produce HCl. That means here Cl minus is gain the H plus ion. H plus ion all called as proton. According to this theory, this is called proton. Here Cl minus is accept the proton, it is converted into HCl. The which substance is accept the proton from another substance? That substance is called base. When you observe this H3O plus, here H3O plus is converted to H2O. In previous part we learned here H3O plus is converted to H2O. That means it lose H plus ion. When you remove the H, here it is not called H plus ion, it is called as proton. Here H3O plus is lose the proton, is converted into H2O. That means here H3O plus is lose the proton, it donate a proton to Cl minus. Here H3O plus is donate a proton to Cl minus. The Cl minus is gain that proton, is converted into HCl. So which is accept the proton, that is called base. Which is donate a proton, that is called acid. Okay, right? When you are consider the forward reaction, HCl is an acid, H2O is base. When you are consider the backward reaction, here Cl minus is accept the proton. Which is accept the proton, that is called base. So Cl minus is called as base. Here H3O plus is ion is converted into H2O. When it is converted into H2O, when it is lose the proton, so which substance is donate a proton to another substance? That is called acid. So when you compare this this equation, you observe one simple point. Here HCl is an acid. When it is donate a proton, it is converted into Cl minus. HCl is an acid. HCl is an acid. HCl is an acid. When it is donate a proton, it is converted to Cl minus. What is the character of this Cl minus base? That means acid is donate a proton, it is converted into base. When the acid is donate a proton, it is converted into base. See, H2O has basic nature. When it is accept the proton, it is converted into acid. That means when the base is accept the proton, the product shows acidic nature. Okay, right? So saw this equation. When the acid is lose the proton minus proton, it is also called as proton. When the acid is lose the proton, the coming product is shows the basic nature. So when the acid is minus proton, and if it is lose the proton, it is donate the proton, the product shows the basic nature. So when the acid is lose the proton, it produce base. The character of the substance is base. Such type of base is called conjugate base. When the base is accept the proton, it shows acidic nature. When the base is accept the proton, it shows acidic nature. Such type of acids is called conjugate acids. Is it clear? When the acid is donate a proton, it shows the basic nature. Such type of bases is called conjugated bases. When the base is accept the proton, it shows acidic nature. Such type of bases is called, when the base is accept the proton, it shows acidic nature. Such type of acids is called conjugated acids. I repeat, when the acid is donate a proton, it shows basic nature. Such type of base is called as conjugated base. The base is accept the proton, it shows acidic nature. Such type of acids is called conjugated acids. Is it clear? We take another example. That is NH3 plus H2O is equilibrium with NH4 plus OH minus. By observing this equation, here H2O is converted into OH minus. That means H2O contain H plus ions and OH minus ion. That means it lose. So here H2O is donate a proton. H2O is donate a proton. It lose the proton. So which is lose the proton? That is called an acid. It is an acid. So when you observe this one, ammonia is converted into ammonium ion. So it has one extra hydrogen and one positive. That means it accepts the proton. It accepts the proton. The chemical substance which accepts the proton, that is called base. It is an acid. When you observe this forward reaction, when you observe the backward reaction, OH minus is converted into H2O. That means it gain one proton, it is converted into H2O. Here OH minus is accept the proton, it is converted into H2O. The chemical substance which accept the proton is called base. So it is base. Here when you observe the ammonium ion is converted into ammonium. That means it lose the one proton, it is converted to NH3. So which chemical substance can donate a proton to another substance is called an acid. When you observe this equation, the base is accept the proton, it is converted into acid. The acid is donate the proton, it is converted into base. Such type of pairs is called conjugated acid base pair. Such type of pairs is called conjugated acid base pair. So our topic is conjugated acid base pair. The definition of the conjugated acid base pair is the acid base pair differ by a one proton only is called conjugate acid base pair. Conjugate acid base pair. So the acid base pair which differ by a proton. We take one example. So here HCl is an acid. HCl is an acid. Cl minus is a base. It is an acid. It is a base. They come together, they form pair. It is an acid base pair. What is the difference between these two? Only one proton. When you are remove the proton, it shows basic nature. When you add the proton, it shows the acidic nature. So the acid base pair differ by a proton. Such type of acid base pair is called as conjugate acid base pair. Okay, right? What is the definition? Acid base pair differ by one proton. When you add the proton, it shows basic nature. When you remove the proton, it shows some nature. ప్రోటాన్ ఉన్నప్పుడు ఒక నేచర్, ప్రోటాన్ తీసేసినప్పుడు ఒక నేచర్, అలా ఉంటే వాటిని కాంజుగేటెడ్ యాసిడ్ బేస్ పేర్స్. ఇప్పుడు మీరు చెప్పండి, ఇందులో కొన్ని ఎగ్జాంపుల్స్ మనం రాయగలుగుతాం. H2O ఈజ్ బేస్, H3O ప్లస్ is an acid. Okay, it is a base, it is an acid. What is the difference between these two? Only one proton. So it is also one example for conjugated acid base pair. Tell me another example by observing this equation. NH3 is the base, NH3 is the base, NH4 plus N is a acid. It is an acid, it is a base. What is the difference between this? Only proton. One is a acid, one is a base. Both are differ by only one proton. That is called conjugated acid base pair. Take another example. H2O is an acid, OH minus is a base. It is an acid, it is a base. Both are differ by only one proton. Such type of pairs is called conjugated acid base pair. Take another example. HCl is an acid. Okay, NaOH is the base, but both are acid base pair, but they are not conjugated acid base pair because both have, so NaOH, it have hydrogen, it is also have hydrogen, so it is not an example for conjugated acid base pair. The conjugated acid base pair means the acid base pair differ by a proton, that is called conjugated. The next topic is neutralization reaction. According to the Bronsted-Lowery theory of acids, the definition of neutralization reaction is the transfer of proton from acid to base is called neutralization reaction, and also defined as formation of conjugated acid base pair, also called as neutralization reaction. According to the Arrhenius theory, the definition of neutralization reaction is acid is react with base, it produce salt plus water is called neutralization reaction. But according to the Bronsted-Lowery theory, neutralization reaction is defined as the transfer of proton from acid to base. Acid is always to donate the proton, base is always to accept the proton. So when the acid is donate a proton, that proton is accepted by the base. Such reaction is called neutralization reaction. We already learned HCl plus H2O giving rise to Cl minus plus H3O plus. In this case, HCl is donate a proton, H2O is accept the proton. That process is called neutralization reaction. The process of transfer of proton from acid to base, this reaction is called neutralization reaction. The process of transfer of proton from acid to base is called neutralization reaction according to the Bronsted-Lowery theory. Definition of neutralization reaction according to the Bronsted-Lowery theory is transfer of proton from acid to base. Next topic is strength of acids. Strength of acids. The strength of Bronsted-Lowery acids is determined as it is depending upon tendency to donate a proton or tendency to accept the proton. Here, what is the definition of acid according to the Bronsted-Lowery theory? The chemical substance which can donate a proton. What is the definition of acid? What is the definition of acid? Which can donate a proton. Which can donate a proton is called acid. What is the definition of base according to the Bronsted-Lowery theory? What is the definition of base? Which can accept the proton, which can accept the proton is called base. Accept a proton is called base. Which can donate a proton is called strong acid. what is the definition of base? Which can accept a proton. Which can donate a proton is called acid, which can accept a proton is called base. But here the strength of acid is which one is called strong acid and which one is called as weak acid. What is the definition of strong acid is the more tendency or great tendency to donate a proton. Great tendency to donate a proton is called strong acid. What is the definition of weak acid? Great tendency అంటే ఎక్కువ ఇవ్వగలడాన్ని ఏదైతే ప్రోటాన్ ఇస్తుందో దాన్ని యాసిడ్ అంటాం, ఎక్కువగా ఇవ్వగలుగుతుందో దాన్ని స్ట్రాంగ్ యాసిడ్ అంటాం. మరి దేన్ని వీక్ యాసిడ్ అంటాం? లెస్ టెండెన్సీ టు donate a proton. Less tendency and great tendency or more tendency. The which acid is more tendency to donate a proton is called strong acid. Which acid is less tendency to donate a proton is called weak acid. Here basis concept is depending upon acceptancy of protons. So what is the definition of strong base? Acceptancy of proton is called base. What is a strong base? Was great tendency or more tendency to accept, depending upon accept, accept a proton. Is it clear? What is the definition of weak base? What is the definition of weak base? Depending upon acceptancy. More tendency of acceptancy is called strong base. What is the weak base? Less tendency to accept a proton. Is it clear? Okay. Acid means donate a proton. So more tendency of donating is called strong, less tendency of donating is called weak. Base concept is accepting of proton. More tendency to accepting is of strong base, less tendency to accept the proton is called weak base. Okay, right? That is the strength of acids. Okay, right? What is the definition of strong acid? The acid which has great tendency to donate a proton is called strong acid. What is the definition of weak acid? An acid which has less tendency to donate a proton is called weak acid. What is the definition of strong base? A base which has a more tendency to accept a proton is called strong base. What is the definition of weak base? A base which has less tendency to accept a proton is called weak base. That is the strength of acids. Limitations of Bronsted theory of acids and bases. This theory could not explain the acidic character of non-protonic compounds like CO2, SO2 and AlCl3. According to this theory, the chemical substance which can donate a proton to another substance, the substance which donate a proton to another substance is called acid. ఏదైనా ఒక సబ్స్టెన్స్ వేరే సబ్స్టెన్స్కి ప్రోటాన్ని డొనేట్ చేస్తేనే దాన్ని యాసిడ్ అంటాం. మరి అది ప్రోటాన్ని డొనేట్ చేయాలంటే దాని దగ్గర ఏముండాలి? కంపల్సరీ హెచ్ ఉండాలి, అవునా కదా? ఇట్ ఈస్ కన్వర్టెడ్ ఇంటూ హెచ్ ప్లస్. ఇట్ షుడ్ హ్యావ్ ప్రోటాన్. ఇన్ దిస్ ఎగ్జాంపుల్ CO2 దగ్గర ప్రోటాన్ ఉండే అవకాశం లేదు, SO2 దగ్గర ప్రోటాన్ ఉండే అవకాశం లేదు, AlCl దగ్గర ప్రోటాన్ ఉండే అవకాశం లేదు. కాబట్టి ఇవి ప్రోటాన్ డొనేట్ చేసే ఛాన్స్ లేనే లేదు. కాబట్టి ఇవి యాసిడ్స్ అయ్యే అవకాశం అసలే లేదు. కానీ ఎక్స్పెరిమెంటల్లీ దే ఆర్ యాసిడ్స్. బట్ దిస్ థియరీ ఫెయిల్ టు ఎక్స్ప్లెయిన్ ది acidic character of such type of compounds which do not have proton. So this theory could not explain the acidic character of non-protonic compounds like CO2, SO2, AlCl3. ఈ థియరీ ప్రకారం యాసిడ్ అయి ఉండాలంటే అది ప్రోటాన్ డొనేట్ చేస్తేనే యాసిడ్. కానీ ఇక్కడ CO2 SO2 AlCl3 లాంటి కాంపౌండ్స్ ప్రోటాన్ డొనేట్ చేయకపోయినప్పటికీ అవి ఎసిడిక్ క్యారెక్టర్ను చూపెడుతున్నాయి. అటువంటి వాటి గురించి బ్రోన్స్టెడ్ అండ్ లూరీ సైంటిస్టులు ఎక్స్ప్లెయిన్ చేయలేకపోయారు. దట్ ఈస్ వన్ ఆఫ్ ది limitations. So next one, it could not explain the neutralization reaction which proton transfer does not takes place. మనం ఆల్రెడీ న్యూట్రలైజేషన్ రియాక్షన్ డెఫినేషన్ నేర్చుకున్నాం. వాట్ ఇస్ ద డెఫినేషన్ ఆఫ్ న్యూట్రలైజేషన్ రియాక్షన్ అకార్డింగ్ టు ద బ్రోన్స్టెడ్ లూరీ థియరీ? ప్రోటాన్ ట్రాన్స్ఫర్ ఫ్రమ్ యాసిడ్ టు బేస్ ఈస్ కాల్డ్ న్యూట్రలైజేషన్ రియాక్షన్. న్యూట్రలైజేషన్ రియాక్షన్ అంటే యాసిడ్ నుంచి బేస్కి ప్రోటాన్ ట్రాన్స్ఫర్ అయితేనే దాని న్యూట్రలైజేషన్ రియాక్షన్ అని బ్రోన్స్టెడ్ అండ్ లూరీ సైంటిస్టులు ఎక్స్ప్లెయిన్ చేశారు. కానీ కొన్ని రియాక్షన్స్లో CaO ప్లస్ CO2 గివింగ్ రైస్ టు CaCO3. ఇందులో ప్రోటాన్ ట్రాన్స్ఫర్ ఏమైనా ఉందా? ఒక కాంపౌండ్ నుంచి ఒక కాంపౌండ్కి లేనే లేదు. అయితే అటువంటి వాటిని న్యూట్రలైజేషన్ రియాక్షన్ అనలేము. కానీ ఇవి కూడా న్యూట్రలైజేషన్ రియాక్షనే. ఎందుకంటే ఇక్కడ సాల్ట్ ఫార్మేషన్ జరిగింది. CaO ఈజ్ అ బేస్, CO2 ఈజ్ అన్ యాసిడ్ బేస్ రియాక్షన్లో పార్టిసిపేట్ చేసి మనకి ఒక కాంపౌండ్ ప్రొడ్యూస్ చేసాయి కాబట్టి దీన్ని కూడా న్యూట్రలైజేషన్ రియాక్షన్ అంటాం. కానీ ఈ థియరీ ప్రకారం న్యూట్రలైజేషన్ రియాక్షన్ కావాలంటే ట్రాన్స్ఫర్ ఆఫ్ ప్రోటాన్ టేక్స్ ప్లేస్ ఉంటేనే దాన్ని న్యూట్రలైజేషన్ రియాక్షన్ అంటాం. అంటే ఈ థియరీ న్యూట్రలైజేషన్ రియాక్షన్ ఎలా డిఫైన్ చేసిందంటే సబ్స్టెన్స్కి యాసిడ్కి బేస్కి మధ్య ప్రోటాన్ ట్రాన్స్ఫర్ ఉంటేనే దాన్ని న్యూట్రలైజేషన్ రియాక్షన్ అంటారు. కానీ కొన్ని రియాక్షన్లో ప్రోటాన్ ట్రాన్స్ఫర్ లేకపోయినప్పటికీ కూడా న్యూట్రలైజేషన్ రియాక్షన్ జరుగుతుంది. ఎగ్జాంపుల్ HCl ప్లస్ NaCl ప్లస్ H2. దీంట్లో కూడా ప్రోటాన్ ట్రాన్స్ఫర్ లేదు, కానీ ఇది కూడా న్యూట్రలైజేషన్ రియాక్షన్. ఏ థియరీ ప్రకారం? అర్హీనియస్ థియరీ ప్రకారం. కానీ ఈ థియరీ ప్రకారం ఇది న్యూట్రలైజేషన్ రియాక్షన్ కాదు. కాబట్టి ప్రోటాన్ ట్రాన్స్ఫర్ లేని రియాక్షన్స్ని, న్యూట్రలైజేషన్ రియాక్షన్ని ఈ థియరీ ఎక్స్ప్లెయిన్ చేయలేకపోయింది. ఈ రెండు కూడా బ్రోన్స్టెడ్ లూరీ థియరీ యొక్క లిమిటేషన్స్. ఓకే, thank you students. This is T Balakrishna, chemistry lecturer, GPT Kothagudem. Thank you very much.